Hey everybody, welcome to our first video on kinetics. We're going to introduce some of the ideas related to chemical kinetics, which is chapter 12 in our textbook. And we're actually here in my backyard at home, and I think this is a great place to introduce kinetics because it shows us some of the neat changes that we know go on in nature, like the leaves changing behind me. Now, we spent the previous unit talking about thermodynamics, and hopefully you recall that the main question we were asking and answering there is a particular chemical reaction possible? Is it spontaneous? Does it favor products? Well, here in the leaves changing behind me, we have a chemical reaction that's going on. Now, through most of the summer, the thermodynamic conditions aren't what they need to be for the leaves to change. But then as the weather cools down and some other events happen, the possibilities that the leaves can change starts to become thermodynamically possible. And so slowly over the course of September and October and November, the leaves begin to change. And the rate at which that happens is really the realm of chemical kinetics and the focus of the unit that we're going to be doing for the next month and a half or so. So we're going to introduce some ideas here related to chemical kinetics. Now, just to make a little space here, I'm going to go ahead and get rid of my title, and I'm going to zero in on this chart here, which we saw quite a bit when we talked about thermodynamics. So now that we understand thermodynamics, we have free energy on our y-axis and time or extent of reaction on the x-axis. We have our reactants that eventually turn into products. So the reaction I'm showing here, the reaction coordinate diagram it's called, if you remember, is this one spontaneous or non-spontaneous? Well, the free energy of the reactants decreases as it turns into products. So this is a spontaneous reaction. It's thermodynamically downhill, as it were. Now, when you've looked at reaction coordinate diagrams, you've always seen this profile of the hill that connects the reactants and products. And in chemical kinetics, the story is now actually going to be all about the hill. In thermodynamics, we were concerned about the difference between reactants and products. We did calculations where we did, thermodynamic quantities of the products minus thermodynamic quantities of the reactants to get the change. And the change is important. The change is fundamental. But now we want to get into the nitty-gritty. What's going on as we go over the hill through the pathway of the chemical reaction? And there are going to be some really key ideas that we're going to run into as we take a closer look at the pathway. For example, what's going on with, say, the height of that hill? All right? Different chemical reactions have barriers that are taller than others or smaller than others. The height of this hill, as we'll see as we get later on into this unit, is called the activation energy. And this is the energy it takes for a chemical reaction to get started. Now, a reaction could be thermodynamically favorable, say the combustion of propane, like the propane grill I have over here on my deck. We know that's a spontaneous reaction. But we also know that you have to give it a thermodynamic push, that you have to light a match. I have to click on the lighter over there on my propane grill to get it to start. And that spark, that little flash of energy, is what we would call the activation energy. There's a barrier to getting from reactants to products. So we're going to spend our time talking about the pathway here in chemical kinetics. And not all reactions have one hill, like I'm showing here. Some reactions are going to have a couple of hills, or maybe even, who knows, 3 hills. We're going to get into the nitty-gritty of that. When you start to look at the way a reaction happens, the actual molecular events that transpire to get it to happen, you're taking a look at the reaction's mechanism. Mechanism is an important word. We're going to come back to that. At the heart of chemical kinetics is understanding rates, how fast a reaction's going. And you can see a little bit of information about rates in the bottom right-hand corner of this guy over here. And we're going to get into this in more detail in the next video, but I'm showing here kind of a profile of the reactants and products involved in a reaction. What we're showing here, and again we'll see this in more detail next time, is we're showing the decomposition of, and I want to make sure I don't move that too much, is we're showing the decomposition of NO2 and the formation of NO and the formation of O2. And you can see these reactants and products have their own curve as they transpire over time, as they decompose over time, or as they get formed over time. And the shapes of those curves and the relative sizes of those curves is one of the first key ideas we're going to get at when we start to look at chemical kinetics. So the first thing we're going to do, and the next thing we're going to do in the next video, is take a look at rate information when it comes to chemical kinetics. Okay? Till next time.